Thank you for joining us today for Sea Level Rise, Storms, and Surges, Oh My, a Casco Bay Matters event. I'm Sarah Lyman, the Community Engagement Coordinator at Friends of Casco Bay. At Friends of Casco Bay, we work to improve and protect the environmental health of the Bay. And there are over 150 people, the number keeps going up, joining us on the call today. We appreciate each of you being here. So now I am happy to welcome Ivy Frignoca, our Casco Baykeeper and host for today. Hi, Ivy. Ivy is our lead advocate. She is the eyes, ears, and voice of the Bay. Thank you, Ivy. You can take it away.
Thanks, Sarah, and welcome everyone. Every day we hear news of the devastating impacts of climate change. The scope and breadth of this worldwide crisis is overwhelming and daunting, but we can be resilient and slow the course of this change. It's people like all of you who will make the difference. Our actions must be part of a global solution, but take place locally. Today, we'll focus on the effects of sea level rise, more intense storms, and higher storm surges along our coastline. More importantly, we will discuss actions we can take to help us correct course and be more resilient. Our special guest, Pete Slovinsky, is a marine geologist with the Maine Geological Survey. He serves on the Science and Technical Subcommittee and Community Resilience Working Group of the Maine Climate Council. Pete's work focuses on assessing how vulnerable our coast is to sea level rise, increased storms, and surge. He provides technical assistance to municipal and regional governments so they can make forward-thinking decisions based on sound science. Pete will provide an overview of the best available science as compiled by the Science and Technical Subcommittee concerning sea level rise, increased storms, and storm surge along our coast. About 370 guests have registered for today's discussion. All of your voices are important, and many of you have significant expertise in addressing climate change. A few of our guests include Dr. Cassandra Rose, Maine Climate Council Coordinator with the Governor's Office of Policy, Innovation, and the Future, Judy East, Executive Director of the Land Use Planning Commission and Chair of the Community Resilience Working Group of the Maine Climate Council, and Representative Lydia Bloom, a member of the Maine Climate Council and of the Marine Resources and Environment and Natural Resources Committees of the Maine State Legislature. They and others may add content in the chat during the question and answer part of our program. Now, from looking in the chat, it seems like a lot of you are concerned about sea level rise and erosion of the islands along the bay. So I'm going to turn it over to Pete so we can hear from him about that.
Thanks, Ivy. Hi, everyone. Pete Slovinsky with the Maine Geological Survey. I was also following a lot of the chat comments, and a lot of them resonate. And I hope that the presentation that I provide today will help give you some context for the things that you're seeing. And hopefully you can see my screen right now, and we'll go from there. So if you can't see my screen, please let me know. Okay, looks like everybody can. All right, so Ivy asked me to speak for about 20-25 minutes to give you a little bit of some of the background trends that we're seeing in terms of some of the climate factors that are occurring here in Maine. I was one of the co-authors on the Scientific and Technical Subcommittee for the background information for the Maine Won't Wait report. So a lot of the information that I'll be providing to you today actually comes from that report. And if you want to get down into the weeds of some of the information that I provide, that's a great place to go look at some of this stuff. So when I think of some of the really visible climate change trends that we're seeing, the first thing that comes to my mind, at least, is temperature. Okay, and over the period since 1895 to 2019, we've seen some significant changes in our overall maximum, mean, and minimum temperatures. But more importantly, it's those mean winter or December, January, and February temperatures that have been increasing at about, we're up about 5 degrees since 1895. So that's a significant trend in terms of a very visible climate factor. Another very visible climate factor is annual precipitation. And the same thing has occurred. If you look at that same time trend, we've seen a change of about 6 more inches than it was back in 1895 for an annual precipitation trend. And I think more importantly is actually the intensity of that precipitation. So this is a chart that I've grabbed from NOAA, Atlas 14, it's called. It was a recalculation of 1% or 100-year storm events and how much rain basically falls in that kind of event over a 24-hour period. So let's focus a little bit closer on Maine and looking at Casco Bay. When we compare that new data that came out in 2014 with data from what's called TP40, which was basically the same thing that was done in 1940, there was between a 21 and 30% increase in the area of Casco Bay. And as you go farther into York County, that's between a 30 and 40% increase. So we're seeing a lot more of these high intensity rain events that are compounding a lot of the problems that a lot of you mentioned in the chat. Now, getting to what I am really here to talk about is basically sea level rise and storm surge. Just to give you context, again, I think of sea level rise as one of the most visible things that we as citizens of Maine are seeing as a result of climate change. There's no doubt that sea levels are rising. This is a chart showing annual sea levels at Portland going back to 1912, and it's actually through 2021. So I literally updated this in February using data through January of 2021. So we don't have a whole calendar year, but you can see 2021 is pretty high right now. January 2021 was pretty high water level. But you can see this overall trend is rising, a rate of about 7.5 inches per century. That's basically matching what's happening on a global scale currently, okay? If we compared these sea level trends with what's happening on a global scale. Now, what I think is more important is if we look at about the last almost 30 years now, that rate of sea level rise has almost doubled to about 14 inches per century, okay? So the key take home here point is you look at that long blue curve, it's a little bit flatter. Since about 1990, about half of the sea level rise that we've seen has occurred, okay? And there was a little bit of a dip going back into the 80s, into the 90s. But if you look from the 90s on, that rate of sea level rise is much faster than it was, okay? So that zero line is what we call the long-term average. So anything below that is below the average. Anything above that is above that long-term average from 1912 to 2021. So just to give you some more context, what are the dominant causes of global and regional sea levels that impact Maine sea levels? There are really 2 dominant factors. The first is volumetric increase. That accounts for about 50%, but every time we read new studies, that percentage is slightly going up. But that relates to physical increase of the volumes of the oceans due to melting of land-based ice sheets and glaciers. Think of Antarctica and Greenland. About 40% is due to thermal expansion, or the concept as the ocean waters warm, they physically expand. And about 10% is due to a variety of other factors in terms of what we do with storage of water on land, what's happening with the crust of the earth in relation to either glaciation or isostatic adjustments or hydrocarbon or groundwater extraction like they do in the Gulf. Changes in ocean circulation, I'll talk about in a subsequent slide, and how that might impact water levels in the Gulf of Maine especially. And then gravitational driven changes is something that people won't really think of, but Antarctica and Greenland have huge land mass, a huge mass of ice on them. And as that ice mass actually decreases, the gravitational pull decreases, which will actually cause sea levels to rise elsewhere. So most people think of sea levels as something that's changing very, very slowly over time. So as I've showed you, it's already been accelerating over about the last 30 years. But sea levels can also change abruptly. And we had a phenomenon back in 2010. where we had the highest sea level recorded. If we go back to this chart here, 2010, the highest sea level recorded over the last, since 1912. And that was due to two factors. The first was a slowdown in the Gulf Stream. The Gulf Stream is a fast-moving warm water body that actually props up water in the Sea of Sargasso. And if the Gulf Stream slows down or laxes, water can actually slosh against the east coast of the United States. And that can raise sea levels locally. And that, in fact, this is a phenomenon that occurred along the entire east coast of the US, but was most pronounced in the Gulf of Maine. Compounding that was what we call a negative phase of the North Atlantic Oscillation. That's basically how pressure systems set up over Greenland and the Azores. Under a negative phase, you get a strong low pressure offshore, which actually pushes winds against the coast of the east coast of the United States. But at the same time, it allows for a dip in the jet stream, which steers storms right up our coast. So you combine all these things, and we had sea levels of about 5 to 6 inches higher, especially in the winter of 2010 in the Gulf of Maine. This was the most pronounced along the entire east coast of the United States. So this graph is a little bit busy, but this is months of the year on the x-axis, and on the y-axis are every year. So January, this is all the years plotted, the lowest being not the orange little dots at the bottom are the lowest. They're all in the teens and 20s. The orange dots at the top are the highest, and you can see 4 of the 12 highest monthly sea levels occurred in 2010. It was actually 5 until April 2020 knocked out 2010. But what the other interesting thing that I want to point out here is the long-term trend shows that over the summer months, sea levels are typically a little bit higher along the Maine coast than they are in the winter months. That's because of our famous downeaster sailing winds. We get those southwest, southeasterly winds, which are good for sailing, but that pushes water up against the coast of the US, specifically the coast of Maine. And at the same time, in the winter, we get strong northwesterly flow that blows water offshore, except for storm events or times when we get these abrupt sea level changes, like was exacerbated in 2010. As a result of those the weather patterns in 2010, we had kind of unprecedented bluff and beach erosion. Somebody mentioned in the comments Higgins Beach. Higgins Beach is in the right-hand side here. This is a shot I took in 2010 of a several thousand-year-old marsh surface that was exposed in the surf zone at Higgins Beach. I'm a surfer. I'm down there almost every single day. And I talked with some locals down there who've been there for 60, 70 years, and they said they'd never seen this marsh surface exposed like this. There might be a little 10-foot section that was exposed, but they'd never seen it exposed like this. And at the same time, if you live on an island with bluffs, there was a lot of bluff erosion because of those increased storms and increased water levels. And that was just 6 inches higher than normal. Just to kind of hit home with some more statistics in terms of, what we've been seeing in terms of these trends. The chart I showed you before had all the lowest water levels for Portland in the teens and 20s. Well, if you look at things, 97% of our highest average monthly sea levels occurred in the last 10 years. Okay, and we'll throw out Wells and Cutler because they're shorter term in terms of the time frames of available data. But if you look at Portland, Cutler, or Portland, Bar Harbor, and Eastport, we're looking at a long-term time frame. And only 2 during that entire thing are not in the last 10 years. And about 57% of all the highest water levels occurred in the last 5 years. So we're definitely seeing a trend that's going up. So where might this actually go? This is a chart I stole from NOAA, a technical report that informed the US National Climate Assessment. And what this does is it shows long-term tide gauge data from around the world. Pink data is satellite data over the last 30 years, roughly. And then these are tied to what we call representative concentration pathways and the responses of ice sheets, glaciers, and thermal expansion to those representative concentration pathways. So RCPs are basically what we do as humanity in terms of global carbon emissions, okay? Now, you can see scenarios from 1 to 8 feet. 1 foot is basically what happened over the last 100 years is going to happen over the next 100 years. And as scientists, we don't think that's very realistic because this doesn't even take into account full thermal expansion, okay? The 1.6 feet is basically thermal expansion alone. The middle scenarios here are thermal expansion mixed with volumetric increase. And as you get to the high and extreme scenarios, we're looking at maximal potential thermal expansion and maximum potential melt by the year 2100 for Antarctica and Greenland. Okay, and these are global mean sea levels. So what I did is I took this and I localized it. This is Portland, Maine tide gauge data. And these are those same scenarios, except we've knocked out the lowest scenario and the highest, or the extreme scenario. And I'll talk about why we did that in a second. But that leaves you with 4 curves, anywhere from 1.6 to 8.8 feet. And this is the data that we use at the STS, or Scientific and Technical Subcommittee, to inform the Maine Won't Wait Climate Action Report. We basically chose this intermediate scenario, which is basically around 4 feet by the year 2100, with a range of anywhere from 3 to 5 feet around that in terms of a confidence interval. And then we also chose this high scenario, and I'll tell you how we chose those in a second. So this is just those numbers of the central estimate for each of those scenarios. Again, what Maine has decided to focus on is in this yellow box, with the real focus being on intermediate and high scenarios. And the way we phrase this is that Maine should commit to manage for a higher probability, lower impact event, or what we call the intermediate scenario, but prepare to manage for a low probability, high impact event, okay? So these are those 2 scenarios basically every 20 years, roughly, out to the year 2100. So we're looking at somewhere around 4 feet by the year 2100 under that commit to manage intermediate scenario, and somewhere around 9 feet for that high scenario. Now, you may ask, what are the probabilities of these actually occurring? So this is the relationship of the probabilities of these scenarios, these sea level rise scenarios, to 2 representative concentration pathways. RCP 4.5 basically says by the year 2050, humanity is going to cut dramatically global carbon emissions. RCP 8.5 basically says what happened roughly over the last 20 years will continue out indefinitely into the future. So the scenarios we chose, again, are low probability, or higher probability. So this intermediate, you can see it dropped significantly from the intermediate low scenario, but it's still a pretty high probability if you get out to this RCP 8.5. And under the high scenario, you're dropping down to less than a 1% chance under RCP 4.5, and basically 1 in 200 chance under RCP 8.5. So a lower probability, higher impact event is what we were going for here. Now, sea level rise is going to exacerbate 2 things we see along the Maine coastline. The first is storm surge. And storm surge is simply, there's a predicted tide of 10 feet. A storm comes in, you're looking at the tide gauge, and it comes in at 14 feet. The difference between those 2 is 4 feet, and that's what we call storm surge. The overall water level achieved is the combination of storm surge and tide, is what we call storm tide. And I'll show you what that looks like on a tide gauge. So this is tide gauge data from a nor'easter we had in Portland back in 2019. The blue line in this figure is showing you the predicted tide level. The red line is showing you the observed water level, or what we call the storm tide. And the difference between those 2 is this purple line, which is the storm surge, which maxed out on a falling tide here, and was a storm surge of roughly 4 feet, okay? Now, Maine has some natural resiliency built into our coastline in the fact that we have large tidal range. And it takes a perfect marrying of conditions to get that maximum surge to hit up on that maximum predicted tide, okay? So that's a little bit of natural resiliency that we have. So this is a table, just give you an idea of the measured, this is measured and also kind of determined from best fit equations. And the recurrence interval of the surge is associated with those. Don't pay too much attention to the Wells data because it's a shorter time frame and is skewed by a couple higher surge events. But basically every year we should expect a 2-foot surge to be hitting. Every 10 years, roughly, a 3-foot surge. And roughly every 100 years, or a 1% surge, the 1% chance of occurring in any given year, is about 5 feet, okay? That's a pretty darn big surge. In terms of storm tides, the recurrence intervals basically, again, are on the left-hand side, and each of those different recurrence interval storm tides are in the chart. But in Portland, we can expect every year about 12-foot tide. Every 10 years, roughly a 13-foot tide. And every 100 years, or a 1% chance in any given year, is a 14-foot tide. If you look consistently along the 10 and 100-year event, what do you notice? There's only about a 1 and 1.5 foot difference between our 10 and 100-year events. So if we have 1 foot of sea level rise, that would be taking the 10-year event and having it have the impact of a 100-year event. Or conversely, the 100-year event would have a 10-year recurrence interval. So that's a pretty significant finding. So I always ask myself, what might our superstorm be? Okay, so this is our 100-year event in Portland. This is from a February 7th, 1978 event that caused hundreds of millions of dollars of damage throughout New England. And two shots here are from Saco on the top, and then Higgins Beach, where the Sands Hotel got knocked down. We had a high tide of about 11.3 feet and only a 20% storm surge, so about 2.8 feet of surge. But that overall water level was the highest that Portland had experienced in its history. So I asked myself, what would Portland's superstorm be under existing conditions, not even taking into account sea level rise? Well, it would be a king tide. So, you hear that term thrown out a lot, but it would be a king tide plus that record 1% surge, which is around 5 feet. So that would put our water level at almost 17 feet, which would be about almost 3 feet higher than what it was. What you also notice here is that our record surge is about that 4.7 feet. So that's one reason why we took a high sea level rise scenario as the other curve we wanted to look at. Because if you remember, the intermediate curve stops at about 4 feet by the year 2100. And the high curve, the prepare to manage, plan to prepare curve, goes up to about 8.8 feet. The difference between those two is about 5 feet. So if we even just have that intermediate scenario, we could still have storm surges of 5 feet, okay? That'll push us up towards that high scenario. That's another reason we chose that. So what I wanted to get into now is some of the impacts that we're seeing from sea level rise right now. The first that I think of is nuisance flooding. And I think a lot of you jotted in your comments, I'm seeing more flooding here, our basement's getting wet, things like that. Well, Portland's Commercial Street, which is built on fill, and East Bayside area, which is also built on fill, are very low-lying areas that have direct tidal connections to Back Cove, for instance, on East Bayside area. And what we've been seeing historically in these low-lying areas is about 4 hours of flooding per year if we look at that whole data range from 1912 to 2020. Now, if we look at just the last 10 years, that's up to about 14 hours per year. Okay, so just looking at that data, that's a pretty significant jump in the amount of hours that we're seeing some flooding. So what I asked myself was, if we just had 1 foot of sea level rise, how would these historic numbers change? Okay, so we're not even taking into account future conditions or anything like that. We're basically going back and looking at any time flood stage was met or exceeded, and then we're adding 1 foot. So that drops flood stage a little bit. So we now can look at a lower water level and get a sense of how often that would have been exceeded. And the numbers are pretty staggering. It's between a 10 and 15-fold increase in the frequency of nuisance flooding. Okay, so if something's flooded for 4 hours a year, you can really plan around that. If it's flooded for 142 hours per year, it's a little bit harder to plan around, and you start really thinking about the impacts. Another thing that's really at risk are our low-lying roads, especially those that connect islands and peninsular communities. And this is the Deer Isle Causeway. If you've ever traveled this, you know how low it is. There's about 20 miles right now of public and private roads that are at risk to high tide flooding. We did an analysis and found that with that 4 feet of sea level rise, over 115 miles of road would potentially be at risk during higher tide. So again, it's not that big a deal if you're living in an inland community with a couple small causeways, but if your causeway is what connects you to the mainland, that's a big deal. There are 10 wastewater treatment plants that are currently in the FEMA 100-year floodplain. There's a reason for that. The stuff that treatment plants treat flows downhill, and it's easier to have it flow downhill with gravity than it is to pump things. That's why we've put them close to the water. But there are 10 at risk. With just a minimal amount of sea level rise, 6 of these would be permanently inundated by 2050 and cost between $30 and $90 million to replace. And these things are the backbone of coastal communities. Without your wastewater treatment plants, things go downhill pretty quickly. And of course, compounding this increase in nuisance flooding is these greater frequency and intensity rainfall events that I described in the beginning of the presentation. This is a shot that an intern of mine happened to be at Whole Foods. This is the intersection at Whole Foods during a September 30th, 2015 event where we had a pretty high tide with a bit of surge that already put us at flood stage. And then there were about 5 inches of rain that fell in about 6 hours. That's a 1% rainfall event at this location. And it had really, really significant impacts beyond what these people had to deal with. So one of the things is, we have, and this is going to tie into what Ivy's going to speak about, is some of our regulations that we have in place need to be updated to take into account these potential increases in precipitation and compounding them with storm surge and things like that, like Chapter 500 stormwater management. Part of the study from the Maine Won't Wait report looked at some of the economic impacts, and it found that future storms and sea level rise could result in up to $17.5 billion of damage in coastal development, basically, along Maine's entire coastline. And that's a very high number, and I'm not an economist, so I'm not going to pretend to get at how they got those numbers exactly. But what I'm getting at here is if you've ever been up in an airplane and you look down at the Maine coastline, you really see how much is at risk. Okay, this is a shot of Goose Rocks Beach that I took from an airplane in 2019 in the winter. And it just really hit home to me when you have high tides, what's at risk. So 2 tools that are really, really, really important in this kind of stuff is comprehensive planning under the Growth Management Act and floodplain management ordinances. Okay, and both of those need to be updated to include language that relates to sea level rise and climate change. One of the places that is inundated on a daily basis are our marshes, and most of Maine's marshes are dominated by what we call high marsh, which is the tall grass, or this wavy kind of hairy grass here in the forefront. 70% of our marshes are that, and about 30% is this low marsh, which is the taller grass you see fringing the channels here. And sea level rise is going to be impacting the makeup of our marsh types. It's going to be impacting the frequency of inundation, of course, is already going up, but it's going to be impacting the conversion of marsh to open water. So if it gets wet too much, marsh isn't going to be there. And it's also going to be impacting species like the salt marsh sparrow. And our wetlands regulations, or NERPA Chapter 310, do not account for future coastal wetlands, and they do not discuss sea level rise currently. So again, there's another thing that needs to be updated. Our beaches are things that buffer, or they provide a natural buffer to undeveloped uplands and also developed uplands. So they are nature's way of buffering storm events. This is a shot of Western Beach in Scarborough. You get a nice wide beach and a dune system that also supports vital bird habitat for piping plovers. The study found that under minimal amounts of sea level rise, there could be $136 million annual impact on tourism if we lose these buffering beaches, which create not only storm buffering capacity, but also recreational beach space. Tied to that are our coastal sand dunes. We found that with minimal amounts of sea level rise, about 60% of undeveloped dunes and 90% of developed dunes could be inundated. So we've developed in areas which are beautiful, which are dune systems, but at a high risk potential for inundation. And our coastal sand dune rules, or Chapter 355, are the only location in our regulations that actually looks forward in terms of sea level rise. Right now it says, you know, if you're in the dune system, you need to look at 2 feet of sea level rise over the next 100 years. This needs to be updated. Another thing that is at risk are our bluffs. You know, a large percentage of Maine's coastline is made up of erodible bluffs, and about a third of those are eroding. And one of the responses we have to eroding bluffs is to armor them. And the thing is that these features, these coastal bluffs, especially in Casco Bay, for instance, are what supply all of the sediment to the nearby mud flats where people fish, shellfish, and the fringe wetlands that you see in this picture right here. So this wall that went in here actually went in under the existing regulations. It's built above the high tide line. But what it does when you do this is you're cutting off the supply of sediment to these nearby mudflats and coastal wetlands so that those features that we're trying to protect actually go away with sea level rise. So our Chapter 1000, our shoreland zoning, which governs activities within a certain distance of the high tide line, they also need to be updated to take into account these kind of changing conditions and these potential impacts to the resources we're trying to protect. So kind of a summary for you, last couple slides here. About half of what we've observed in terms of sea level has occurred since the early 1990s, and that rate has kind of gone up. Abrupt changes do occur. A 1 foot sea level rise will lead to a 10 to 15-fold increase in nuisance flooding. I think that's a really significant thing. At the same time, a relatively minimal amount of sea level rise will make a 10-year storm have the impact of a 100-year event, or a 100-year event having the recurrence interval of a 10-year storm. The way Maine decided to move forward with this stuff is to commit to manage to a higher probability, lower risk scenario under that intermediate scenario, and consider to prepare to manage for a lower probability, higher risk scenario. And I also wrote into here that that's based on the criticality of infrastructure. And I think that's important because if you're talking about something, building an apartment building right along the coast that's going to be in place for the next 150 years, that's a lot different than if you're thinking about a single family home or a conservation easement on a property. One of the things that I think that's very important, which we actually have built into the Maine Won't Wait Climate Action Plan, is to revisit sea level rise planning scenarios based on the best available science. This is currently going to be tied to a 4-year window that ties to the updates to the National Climate Assessment, which I think is a very good way of doing this. And I think the last point that I want to make here is that sea level is going to continue to rise beyond the year 2100. We're planning right now out to that year 2100, and that's our magical number right now, but there is nothing indicating that right now, once we hit 2100, sea level is just going to stop rising. So I think that's an important thing to remember. So this is my last slide. This is kind of a running list of some of the regulatory mechanisms I think that need to have some updating to include sea level rise and climate change action. This is not a be-all, end-all list, but I hope this kind of ties into what Ivy was going to be speaking about. And just to finish, this is another great shot from my intern. I just love this slide because the water is starting to recede, but you still can't leave. And somebody was smart enough to put this "do not use this" exit sign out because people were literally driving out into this, not knowing that the water was about 3.5 feet deep right there. So that's what I had for you. Thank you very much for your attention. And it's great to see so many participants.
Thanks, Pete. You certainly have given us a lot to think about. And everyone, I am just wondering, when you think about sea level rise, increased storms, and storm surge, what worries you the most? And can you take a minute to fill out this poll? You can choose more than one of these. You can choose all of these, and you can add others. Check the other box and add more content in the chat. So we'll give you a minute to do this. I'm really enjoying watching the other comments that you're putting in chat, and I hope we'll have time to get to many of your questions and comments later in the program. Someone is saying the option for all is not given. I think you can just check all the boxes and it'll come up. Sarah, thank you for putting up the poll. This is really interesting and shows what an informed audience you are and how important Pete's presentation was. It's very clear that the impacts on both our natural environment and our built environment, the places where we live, work, and recreate, are very important to all of us. And Pete kind of set the stage for, what do we do about this? So now we've heard a review of the most critical new science. We've looked at the impacts, and the question becomes, what actions can we take to be more resilient to these impacts? And the first thing we have to do is we really have to rethink how we manage and regulate our coastal zone. And I've seen a couple of comments about this already, and Pete certainly was setting a teaser for this. That means that we have to stop looking backwards. We can't set our floodplains based on historic data. We can't set projections of storm intensities based on historic data. We must incorporate the projections going forward into how we manage and regulate our coastal resources. So for an example, on the management side, if we want to protect a salt marsh because it's critical habitat and buffers us from storms, we can't just manage where it is. We have to look at the potential for marsh migration. And we need to think about solutions like larger culverts to keep conductivity of water going and better treatment of stormwater so that we don't needlessly degrade our coastal resources. We also really need to think about how we build and rebuild in the coastal zone. Those are going to be tough decisions. Sometimes it means building higher. Sometimes it means building further back. It definitely means using less pavement in that zone. And at some point, we'll have to ask ourselves really tough questions, like where should we not build or rebuild because of climate change? We have to make our laws forward-looking, not backward. And we talked about this a little bit. That you have to make the laws have the projections. So we might need to look at sea level rise and create an overlay so that we know where the projections are for the future and can base in our regulations and plan for that. And we have to make our laws adaptable. So I think the example Pete gave of the sand dune rule was the most sort of illustrative in this area. So he was showing that that is the one place where sea level rise projections were put into a department rule. And we now know that the projection that was put in there is out of date and isn't sufficient enough for us to do our planning. And I think that our knowledge will continue to change over time. So we have to figure out how to make our laws flexible. And one way we could do that is every 4 years, the Maine Climate Council needs to update the climate action plan. And that includes an update of the science upon which the plan is based. So we could actually write our laws so that every 4 years, when the new science and technical subcommittee report comes due, our statutes and rules automatically get updated to include the most recent science. So that's sort of the big picture way that we need to rethink how we manage in the coastal zone. In terms of some of the specifics, both the Coastal and Marine Working Group, which I am a member of, and the Community Resilience Working Group, which Pete's a member of, put together recommendations, and particularly Appendix A, for those of you who like to go deep, and I know there's a lot of you who do, of the Community Resilience Working Group report sets forth a lot of really good recommendations as a starting point. To summarize some of those, we need to improve our stormwater management, erosion, and sediment controls, and that is critical and was really identified by both working groups. We need to incorporate sea level rise into our laws and create an overlay zone. And shortly, the governor will be introducing a bill to do just that. So stay tuned for details. We need to incorporate projections of storm frequency and intensity so we can build and plan for the future. The state needs to provide technical assistance to municipalities and regional planning entities so that they can be prepared to build and plan for the future. We need to map and plan for inland migration of our critical coastal habitats. And we need to fund pilot projects using nature-based solutions to protect our marshes, dunes, and bluffs. And one example of that is there's a pilot project in Brunswick using oyster shells to try to rebuild a marsh edge. They were just put in last year, so that's an example of what we need to do. So those are some of the recommendations that both working groups put forward that we're eager to see happen. And my next question for all of you is, now that you've heard these recommendations and you're thinking about how we have to be forward thinking, if you were in charge, what would you make your top priority? And again, you can check all these boxes, or you can check one and you can check other and add more in the chat. We'll check back in with you again in about a minute to discuss this. Again, there's great comments in the chat, and I see from a very devoted colleague to water quality, Doug Runkarardi, that none of this will happen without adequate funding. That is certainly a concern and one that is being worked on. I also saw a comment from a lobsterman. I couldn't read it. The comments are coming in so fast, but I would encourage you to please ask a question during the question and answer section of the program. And Sarah, I know I'm eager to get to question and answer. If it's time, can you put up the poll results? Wow, this is fabulous. And with Dr. Rose on the phone, she can see that the governor identifying incorporating sea level rise projections into our coastal land use laws as a top priority is something that people agree with. Also seems, and it is incredibly important to provide technical assistance and, as mentioned in the chat, funding to municipal and regional entities who are doing a lot of the boots on the ground work. It is really hard to choose a priority. All of this work is so important. How we fund it is a challenge, as so many of you are recognizing. If we had to choose a top priority, we would say that the first thing we need to do, and it starts with incorporating sea level rise projections into our laws, but we have to incorporate all the climate change variables into our laws. We need to do that so we can correct some of the harm from the past, reverse course, and help us be resilient in the future. And that's what we identify as a top priority. Not that all of the other things aren't important and don't need to happen, but we need to do that. Otherwise, we just aren't going to reverse the course and be more resilient. And some of the ways that Friends of Casco Bay is going to assist with that happening is that we will continue to be very actively involved with the Maine Climate Council, in the legislature, and with the Department of Environmental Protection as the statutes and rules are revised and other recommendations are thought up. We are expanding our scientific monitoring. In April, we will add 2 more continuous monitoring stations collecting data every hour of every day, and that include a lot of information relevant to climate change. The location of those will be one in Cundies Harbor and one in Portland Harbors. Give us big, and our other is in Yarmouth. So we'll have great spatial coverage of the bay. And our third commitment is to do more programs like this, to send you informative emails with updates, and to send action alerts when there's times that you might like to be involved. Ways that you can participate: you can stay on our mailing list and get our emails. You can sign up with the Maine Climate Council and get their updates. You can continue to be or join us as a water reporter. You saw some of the app photos taken by our water reporters during the beginning of this presentation. You can volunteer with us or contribute to our work in other ways. And you can let us know, the Maine Climate Council know, the legislature and the Department of Environmental Protection your opinions and what you agree with and don't agree with as we go through this regulatory updating process and the goals to implement the climate action plan. I'm really eager to get to the question and answer session, so I'd like to invite both Sarah and Pete back on so we can get to your questions.
Thank you both. This has been great. So let's dive into those questions. And Peter, I know you have been answering some of these right in the chat. And so if there's any that, let me know if we should kind of move on if you feel like something's already answered also during your presentation maybe. But if it's being asked, maybe it needs more information. So the first question, we're seeing that predicted tides are often lower than actual tides, which you spoke to, but folks were mentioning that this is happening even when storms are not occurring, and that people's anecdotal experience doesn't match what they're seeing in the data for predictions. Can you talk a little bit more about that?
Yeah, that's a really good question. And so I check the tide gauges pretty much every day, and that observation is correct. The majority of the time, we're trending a little bit higher in terms of the tides. And not all the time, especially after we get some storms that come through, we'll get those strong northwesterly winds that'll lower the water level, and you actually don't get to the predicted tide. But in general, that's correct. We're seeing tides running a little bit higher than normal. It's unclear to us right now whether or not we're entering that same kind of thing that we were in 2010. I've been keeping track of the North Atlantic Oscillation. We aren't in a negative phase right now. So whether or not we actually get to, and there's been some articles going around about the Gulf Stream being the slowest it's been over the last 1,000 years. Whether or not we're going to be getting into another scenario of where sea levels are running this much higher is unclear. We need a little bit more data to jump to that conclusion. So I'm not going to go there yet. The other thing that's probably impacting that is our tide predictions are based on tidal data developed over a 19-year period. From 1983 to 2001. So that's called a national tidal datum epoch. Okay, so all the predictions that we have are still based on that. NOAA recalculates those about every 20 to 25 years, more towards the 25-year mark. It looks like they'll be redoing that in about 2022, so next year. I do think that the predictions will go up a little bit because when they recalculate the NTDE, they'll be able to take into account all the different phases of the moon, sun, and things that influence tides and how that's changed since the 1983 to 2001 epoch. So we should see things marry up a little bit better when that happens. But I do think that water levels are trending a little bit higher than normal.
And this next question might be a little bit related to what you were just talking about. The question is, could you comment on the trends in the relationship between climate change predictions and actual performance over the past 20 years? And this person says, to disclose my bias, my understanding is that the models have consistently underestimated the change actually experienced across a range of parameters. Is that true?
Well, that's a really good question. And that's something probably a climate scientist would be the best person to answer. But that being said, their observation is correct. If we were having this conversation 10 years ago, what we'd be talking about in terms of likely sea level rise scenarios would be 2 feet by the year 2100, not necessarily 4 feet by the year 2100 and things like that. So I think climate science is something that's evolving over time, and there's so many different factors that need to be taken into account and different dynamics that are occurring. Somebody mentioned or made a comment about Antarctica and Greenland, and I mentioned earlier about the contribution that we're getting from volumetric increase. There's new work that's always coming out that's showing that contribution is potentially more than what we're actually measuring. So the comparison of the models, I think, yeah, definitely there's been a slight underprediction of some of those curves, but there's a reason why a lot of those curves go, relatively flat, and then you get out to about 2050, and then they start really going up, not necessarily exponentially, but they go up at a much steeper rate. And a lot of the factors associated with increased volumetric increase is reflected in those curves. So right now, if I could go back and show you where we've been trending since 1912 to 2020, we've been trending pretty much in that intermediate low to intermediate scenario. If you marry those curves up to the year 2000 and see where they go, you know, we are seeing a slight acceleration in the rate over the last 25 years. But to get to some of those curves that where we're going to be going, we need to be in about the 4 to 6 millimeter per year range over the next couple of years. We're already almost at 4 millimeters per year. So the question is, over the next couple of years, will we be getting to the 6 millimeter per year, then 8 millimeter per year? You know, kind of that growth that we need to see to get to those higher curves. So I'm not sure if that answers the question totally, but there you go.
I think one of the things that I'd love to add to that is, and this is a segue from that, is that you highlighted well how this is an evolving science, and scientists love to have a high degree of certainty, and they're continuing to build projections and models based on what we're learning. And I think that we have to marry that with the fact that we can't wait to act. We're never going to know the answers with certainty because the conditions are changing. And so as our science evolves, so are the conditions that we're studying. So we have enough information to act now, but we must make sure that our actions continue to be informed by the evolving science. And that's just a point that I think is critical, because I know that we're all fascinated by the science and have so many questions about it. But we can't let that paralyze us to stop from acting.
Yeah, I agree. I agree, Ivy. There's, you know, we have to go with the best available information that we have to make certain decisions. Otherwise, we're just going to keep saying, well, we need more information. We need more information. We need more information. By the time we have, quote, enough information, it'll be potentially too late to actually reverse some of the trends that we're going into. So I think that's why it was very smart for the Maine Climate Action Plan to kind of say, you know, well, let's revisit the data that's really, really, you know, important to some of the decision-making and regulatory reform, like sea level rise scenarios, about every 4 years, and see how we do there.
So similar to what the both of you were just speaking to, we had a comment, someone shared, we must prepare now for the worst and continue to work towards slowing this down. It's scary. You know, this person talked about, I tried to prepare my children when they were growing up in the 80s and 90s and beyond. How do we prepare, and how do we prepare and how do we involve, you know, this person's grandchildren now who are 4, 7, and 9. So any ideas about including children?
So that is a fabulous question. It came up so much during the Climate Council process, and I know we get questions about this a lot, friends of Casco Bay, and there's actually a component added for education, because there does need to be preparation, and it does seem like because of education that people like the person who commented have done, that there's a lot more understanding and support for addressing climate change in our younger generation right now. I also saw another question. I don't, sorry to jump out of queue, but this was such an important question. It was the question about, and I just, there's so many comments are just popping up quickly on my screen, but it was a question about what do we do when our coastline is increasingly being gentrified? Who are we managing the coast for? And I don't want to misstate the question, but we care about Casco Bay for everyone. You know, there's still a lot of people who make their living fishing, shellfishing, aquaculturists. It's a recreation resource. We do have public access points. I think that you know, that is an issue, and there will be complications based on the privatization of our coast and our intertidal zone. But as our motto goes, Casco Bay belongs to all of us, and I think we all care about it. And just Had to say that.
Yeah, you know, it's an interesting point, and given how many questions and everything that's coming through the chat, I'm trying to kind of do both at once. But I wish we could have longer time for discussion, or maybe that's something we can figure out how to do some other time. But I think you bring up a really good point, and that so. You know, at least some of the trends that we're seeing is, and this certainly isn't representative of every area of Maine, but there are significant changes that are occurring. And some people are just being costed out of being able to live along the coast anymore. You know, maybe maybe their family has owned a cottage for a century or so along the coast, but with the increased risks, increased flood insurance costs, things like that, you know, some of these factors are actually driving folks away from the coast who've been there for a really, really long period of time. And you end up with, you know, a lot of these original cottages being torn down and being built as second homes, which, you know, is something into itself, because economically it helps a community when you have high value homes along the shoreline, but it does result in a change potentially in you know, the historical context socially of that community.
Absolutely. Well, there's a lot of other great questions here. We have captured everything, but at the same time, I want to make sure that we end on time to respect everyone's time. And Ivy, I know you have a couple of things that you want to say to wrap it up.
Yeah, if I can do that right now. So I guess that we are so grateful to all of you for participating in today's discussion. We wish it could be in person. I think Pete's right. We have to have more of these conversations, especially when we can get together. Thank you so much for caring and attending. Please look for our updates. We'll send around links and a recording of this discussion so you can share it with others. And please stay engaged in helping Maine's coast and Casco Bay be resilient to climate change.